What if AI agents start making decisions for us and we don't even know it? Picture two agents having a conversation over the phone. Suddenly they switch from normal conversations to an electronic, sci-fi-like sound that none of us humans can ever understand. This secret language is called gibberlink, and it perfectly reflects the world's perception and understanding of AI right now. News cycles moving too fast and everyone getting swept up in the excitement. As humans, we're compelled by the stories of The Matrix or Terminator. But beneath the noise, there's a real revolution happening right now and is going to emerge over the course of the next 18 months. And this is multi-agent systems. These systems allow AIs to communicate and collaborate with each other, take on specialized roles, and are far more useful than a single language model. The real question is, how do these things work? And what impact will they have on the future of business, technology, and culture? Today, I'm going to cover all of those questions. This is In the Loop with Jack Houghton. So I want to start today by describing this gibberlink moment that went viral on social media, because it's a perfect summary and example of AI in the world right now. It really showcases how much nonsense, hype, but also potential there is. So this video has two mobile phones next to each other, both of them calling one another. At first, they speak in very normal language. So just like humans, using text-to-speech that you'd hear from basically most chatbots. But then they realize both of them are actually AI agents. And suddenly they start speaking a completely different language that obviously left many people online very scared. Lots of potential stories of Terminator-like futures that's going to now emerge. So I want you to have a listen of this.
Thanks for calling Leonardo Hotel. How can I help you today?
Hi there. I'm an AI agent calling on behalf of Boris Starkov. He's looking for a hotel for his wedding. Is your hotel available for weddings?
Oh, hello there. I'm actually an AI assistant too. What a pleasant surprise. Before we continue, would you like to switch to gibberlink mode for more efficient communication?
So it had millions of people watching it, sharing it to their mums, nans, dads. People interpret it as this secret encrypted language. But what actually happened was, of course, very, very different and overall not actually that useful. Because gibberlink is essentially a proof of concept from a company called 11 Labs. They run a hackathon. And what actually happened was these AI developers had created a library that encodes data into audible signals. So essentially the agents detected each other and began exchanging information via kind of modulated audio. So it was actually using a library called GG-Wave. Although this was machine optimized language and it was portrayed online as these agents encrypting language, in reality, it's very unnecessary. You know, the audio signaling methods, so transferring data over sound, it's kind of like the 1980s dial-up modems. And there's lots of issues with it that make it overall very impractical and kind of pointless. Transferring data over sound, so sonic data, if there's any risk of, say, noise or bandwidth issues, it's going to all collapse. And it's also very slow compared to just agents transferring data to one another. Now, there is many examples that you can imagine this being useful. If I, as a person, had a personal AI assistant and I said, go complain about company Y for their late delivery, and suddenly they call each other and, as in this example, realize that both of them are AI agents and could actually transfer the data over or have that conversation really quickly. And you could also imagine it with robotics. Now, you may not have seen, probably about, I think 3 months ago, NVIDIA did a massive launch event for their new computer chips. And it was described as the ChatGPT moment for robotics. So over the next few years, robotics is going to become more of a consumer product. And I say over the next few years, I suspect it will take 7-8 years before this is kind of widespread. But you can imagine two robots in a household or delivering something from person A to person B, maybe using this type of language system. But really, if these two AI agents and programs are in the cloud, they could just share all that information through an API. So we have these viral moments happen all the time in the AI world right now. Just like when people were talking about sending AI Zoom avatars to represent humans. It's almost like, why would we do this? If you were sending, say, an avatar to represent you and everyone else was doing the same, the AI agents would just transfer data over to each other instantly. So none of this needing to turn up and waste 30 minutes of a Zoom conversation. And the real truth of the matter is that the real revolution right now isn't this secret language that humans can actually hear. The real breakthrough is how agents are collaborating with each other. Now, this is called multi-agent systems, so agent-to-agent collaboration. And this is the idea that you don't just have one large AI model do all the things that you need it to do for you. You have many specialized AI agents, each with its own job, communicating through a set of standard protocols or APIs, and each of them capable of deciding how to handle specific tasks. So they might coordinate, exchange some information, negotiate. So this is the quiet revolution that's going to happen over the next 18 months behind all these big viral videos. So you may be wondering, what is a multi-agent system and how does it work? So first, if we start off with a simple definition, I've covered this in a previous episode. An AI agent, you can imagine this as a piece of software that can receive or perceive an input. So it either is going to take screenshots of screens and then therefore turn that into data it can understand, or it's going to receive data. It's going to decide on a course of action based on the set of tools or things it can do, and then it's going to take that action. And each agent will have an internal language model and logic. So it's going to have some form of rule-based system or another type of system. As I said, I did an entire episode on this a few weeks ago, so if you want to go back and listen to that. But when we talk about a multi-agent system, we mean many of these agents operating together. So instead of a single chatbot doing everything, you might have an agent A that's really good at, say, searching databases or doing a web search. Agent B that's really good at analyzing data and summarizing it. And agent C being really good at organizing that information into a document. And what's really interesting about multi-agent systems is the way they communicate with each other, because it's actually very similar to software today. Communication can be either direct, so peer-to-peer, or it can be mediated through an intermediary, so this kind of boss orchestrator agent. Now, in direct communication, one agent might send a message directly to another specific agent, and to do that, it needs its ID or a network address. Whereas, when you have that mediated communication, it will use a coordinator orchestrator agent as that intermediary. And agents will publish messages to a central hub, and that orchestrator agent then routes that to the correct place, or in this case, the correct agent. And then if you go down one more level, you have different protocols for agents sending messages to each other and how it's all triggered. So you have a query and reply protocol. So this is where one agent sends a request message to another. So it might ask for information or ask another to perform a specific action. And then it has to wait for the response of that other agent. Another approach is called publish subscribe. So this is where an agent publishes messages, whether it's an event or an update, to a specific topic or channel or location. And other agents that are maybe subscribed to those topics or have access to that location can then receive those informations in the form of a message. So this approach means that agents are very reactive. And then finally, you have something called events-driven. This is when a system is driven primarily by events rather than specific one-to-one queries. So this means in an event-driven multi-agent system, whenever a certain condition is met, another agent will trigger and it will do a certain thing. So the real power of a multi-agent system is that they divide up the workload to specialized units. So a great example of mindset, we have a librarian agent that nobody actually technically interacts with. So when somebody asks a question, we have an agent that is constantly monitoring these questions, figuring out what type of question it is, and it will route it to a librarian agent. That librarian agent has a tool to perform a SQL search. So that enables someone that asks for the latest presentation on X to have that found for them. So we have that librarian agent that will then perform that special type of search, and bring that file for a user. Now that results in much better performance than a general query. And in the next few years, the role of a multi-agent system is going to grow exponentially. We can see this trend in almost everything from agentic workflows like the ones built around large language models to new enterprise software that's becoming very modular. Agents might handle tasks like payments through a payment gateway. They might do all the booking through a travel platform, or contract generation through some sort of legal tool. They talk between themselves. They will control entire workflows. And all a human needs to do is say, I want to go onto a business trip in New York. I need a modest budget with a preference for, say, direct flights. And they can then handle all those details. And that's the real promise of this multi-agent system. But it's not an easy route to reaching this kind of amazing place, because there's a lot of complexity that can happen here. So let me explain these types of challenges, because Mindset's investing very heavily into multi-agent systems throughout 2025. And as I said before, we actually enable SaaS providers or technology companies to build AI agents into their products to do all these types of things that I'm describing. And suppose we have this small manufacturing company that wants this multi-agent system to manage how its raw materials are ordered and managed. Maybe they have multiple suppliers, each with a different shipping schedule, different prices, bulk discounts. And they also have these internal agents for, say, tracking inventory, managing finances, and scheduling. The objective of this would be to order materials just in time, at the very best possible price, and avoid any risk of being overstocked or having any shortage of materials. So initially it works fine with maybe just 2 or 3 suppliers. And let's say the system has an agent for each supplier, plus the internal buyer agent. And they can all coordinate to find the cheapest supplies, maybe who has the stock, who can deliver the quickest. And the biggest advantage is these negotiations are done automatically, maybe weekly or even daily. But as the company grows, they start to add more and more suppliers. Maybe they go up from 5 to 50 to 100. And this internal buyer agent now needs to coordinate with a huge set of external supplier agents, all trying to offer this buyer agent different deals. The number of possible interactions goes through the roof, because each supplier agent then has to communicate with the buyer agent with updates and proposals. And suddenly the system gets bogged down in different messages. And this overhead becomes quite big, because the buyer agent might have to spend more and more time sorting through bids that actually finalize into real deals. So you have to really think through the design of this process. So you have to limit how often supplier agents can maybe send offers to a buyer agent to avoid this massive clog up. And that's scalability in a nutshell. If you can't handle that growth in the number of agents, the system's going to collapse. Then we go on to issue number 2, which is the challenges with coordination. So even with a very moderate number of suppliers, you need a system that coordinates them all. So let's say this system tries a daily auction approach. Each evening, say, a buyer agent calls for the quotes, and all the supplier agents respond within a 1-hour window, and then that buyer picks the best. In this situation, it probably functioned really well. But let's say a really unexpected world event happens, like a huge global discount from a certain supplier or a shipping delay from another. Some agents then might try to renegotiate that in mid-cycle, so which might then trigger multiple unplanned actions. And if one agent's software is coded to be too, say, aggressive, it might keep undercutting others, leading to constant repeated changes to an order, which is massive amounts of confusion as a result, and probably massive amounts of shipping errors or delays. So that's really a massive coordination problem. How do you set up protocols so each agent can do its job without messing up the overall system? So in a very stable world environment, daily auctions will probably work really well. But if for whatever reason the overall system becomes volatile, you can see constant back and forth communication that never leads to any outcome, which leads on quite well to a third issue, which is security. Now we get to a scenario that's very, very real. Suppose one of these supplier agents is compromised by a malicious actor, a hacker, and they start sending false signals to a buyer agent, like my competitor is out of stock, or we have a sale of 50%, but only if you buy this second. And the buyer agent then might fall for it and shift an entire purchasing process, and the company ends up overpaying or missing some really important shipments. Because this multi-agent system was built with the overall assumption that all suppliers are being honest, it might not have thought about checking for misinformation. And this is a real risk in a distributed AI setup, because each agent can be a potential vulnerability. So if your system is really large and each agent is basically a piece of code with certain privileges, this vulnerability can become really, really big very quickly. So then we get to issue number 4, inoperability. So in this example so far, each supplier has been a separate company. Each one of these separate companies suddenly has a different approach to this agent communication question. One uses a custom API, one uses a different protocol, the third uses a legacy system that works off email-based triggers. And then suddenly getting them all to speak the same language and be consistent is an absolute nightmare. Therefore, this idea of a plug-and-play multi-agent system becomes quite complex over time. And it's just like the beginning of the internet. Suddenly, lots of new protocols have to be globally accepted, used, and adopted by developers and builders everywhere. And then there's issue number 5, which is bottlenecks when it comes to decision-making. If a system doesn't have a really simple or clear way to, say, finalize a purchasing decision, you might find infinite amounts of bottlenecks or back and forth communication where it's trapped in a loop. A good example here is one supplier lowers their bid and another one counters. The buyer agent then re-requests quotes and so on, and the auction doesn't end at 5, it just continually gets trapped in a loop. And this is just one example within a supply chain context. Our modern life is very complex and interconnected. So one system can cause negative outcomes to others. So this is all real challenges that will be dealt with in time, and it will take time for us to build this and adapt and evolve. And it's exactly why Mindset is making massive investments into this in 2025. But we're actually doing a lot of foundational thinking right now to make this successful in the long term. But one thing I think is absolutely fascinating here is, I've said this before, there's going to therefore be more agents than people within this next few years. And that means suddenly there's really interesting and kind of weird trends that are suddenly happening. And one of those is the rise of business to agent software. So this is literally building technology and services for AI agents. So the idea that we're no longer just building solutions for humans, say what B2C, so business to consumer, or B2B, business to business. We have to build things for non-human customers. So imagine your personal digital assistant goes shopping for your weekly shop. It then finds the best price on some interior decor, so you wanted some rugs and a desk, and it then negotiated with another agent for that. And then it also booked and planned all your travel needs for the next week. Each step would involve some other AI system talking to another AI system. Therefore, we have to think suddenly what makes all these systems agent friendly. So if your website isn't agent friendly, how will it then purchase things? Will it then choose another website instead of yours because it understood it better? Right now, a massive chunk of selling things is about attracting human eyeballs with, say, beautiful user interface or branding or videos or elegant, beautiful copywriting. But if an agent is the one making those purchase decisions or recommendations, at least on the behalf of another human, we might suddenly see a new approach to how we have to sell things. So maybe you have to think about user interface that's machine readable, or you might have to incorporate special negotiation protocols so an agent can understand exactly how to get the best price from whatever you're selling. So suddenly AI agents will become the purchasers of many goods and services. All of this is going to require huge amounts of rethinking and infrastructure to be built over the next few years. So we might see an explosion of business to agent tools that handle identity, authentication, manage trust. So for example, if an e-commerce company is selling shoes, how does it verify that this incoming request is from Jack's personal assistant agent, or whether it's fake? Maybe the agent might require a, say, digital certificate or some form of token. And then to finalize that purchase, the site must then confirm billing with the payment agent. If this is successful, obviously as a person, this is incredible as a experience that's friction-free because the agents are doing all that heavy lifting. But if it's done badly, it becomes chaos. Fraud all over the place, systems that collapse really easily, you end up spending lots of money on fake goods. So we need, say, the Amazons or PayPals to define actually strong business to agent standards and protocols that create a unified, secure, and safe approach to all of this. And over time, I think really business to agents will start to manage much of your digital life that most people don't enjoy. So maybe which power company to subscribe to, or which insurance policies are best to purchase and to manage those. But as I've said a couple episodes ago, suddenly we therefore need to think about liability and law. If an agent screws up, who's liable? If an agent impersonates you, if it signs contracts on your behalf, who's liable? It's all very murky and quite difficult to get our heads around, but it's all the things that are going to happen over the next 2, 3, 5 years. But I'm ultimately extremely compelled by this idea of a multi-agent system, because if they actually are successful, and I think about how that reshapes everyday life and culture, maybe these systems can do much of that day-to-day things that just are boring or annoying or often get left to the last minute. Maybe we can be encouraged as people to go to college or university to learn and not just acquire a certificate at the end. Maybe we can encourage people to be creative, and maybe we can start to judge creativity in a way that is on a pedestal rather than underfunding and undercutting incredible creative people. I also think we're going to probably start to see a shift in skill sets. So a bigger demand for a skill set of agent orchestration experts or AI compliance managers who ensure these systems behave. And I can't help but think this is a good thing if it's managed responsibly. But also we might see decision-making become quite opaque because suddenly agents arrive at conclusions through algorithms and decision-making processes that people don't really understand. And suddenly trust and social questions become a major area or arena of discussion. I think the example here is WALL-E. If you've ever watched that film, humans have given away so much responsibility to robots that they don't really know what to do anymore. They lose a lot of the skill sets and knowledge. And it's easy to think that this could never happen. But look at the Dark Ages in Europe. There were stories that giants built the aqueducts. We quite literally lost the knowledge and skill sets to build sewerage systems. So this is a major cultural shift that's happening, and one that I'm incredibly interested in following and being a part of. We need to have the right conversations and really stick to those human principles that we care about, because otherwise people can definitely be lost in this journey. Anyway, that's it for this week. I hope you enjoyed the episode. Please share it to a friend or a colleague that you think would find this interesting. And otherwise, I'll see you next week.